So I touched upon, for the mechanical side of it and then validation. But of course, just like you have upstream industrial design process, wherein you need to ensure that everything is correct by validating multiple options and selecting the best option out of, whatever available. But apart from that, in order to manage the complexity of multidisciplinary engineering, there is a concept which has been widely adopted into the industry is model-based systems engineering. Okay, so in model-based systems engineering, you break down your requirements to the functional level. Okay, what different functions my vehicle need to perform, and then you can break it to the logical architecture, and then finally you basically detail out that logical architecture to come up with the physical system. How it helps is you can bring it back those components with various stages of verification, validation, and qualification, right? So this entire, what we call it as V curve, really helps the organizations to manage the complexity and to have the predictability in terms of performance of the vehicle. So this 3D experience platform, what we are talking about, has got that backbone of model-based systems engineering, which can be leveraged to a greater extent for handling such complex systems.
Okay. Dev sir, any inputs from your side related to this design, modeling, and simulation of EV?
Yeah, I think Rupesh has covered it very nicely across the whole comprehensive design requirement for a electric vehicle, the mechanicals, the electricals, the powertrain, and the whole, the entire EV platform. So I would only say that, there are, these are very powerful tools, and we have to, OEMs have to utilize these tools and technologies today. See, the whole success depends upon couple of things. One is that, the timeline. Today everybody is in a hurry, and we have to, whatever stage of business you are in the early stage, maturity stage, or later stage of declining, you have to shorten the the product life cycle basically, and then come up with something, either a new product, new technology, new platform. And second is, now going forward, customer wants customized products. It's the age of customization. Tomorrow maybe we'll have to build cars customized to customers' requirement, who will order probably online to us. So that's probably is coming soon. So these are the tools. Without that, it's not possible to my mind to really design a high technology product like car, and especially EV, because as Rupesh said, the safety is a very important part. These are all high voltage systems. And also, the NVH requirement, for example, are totally different from the IC engine vehicle. So, the whole simulation has to be done customized to an EV. Also, the heat generation, the entire electrical system, the cabling, wiring harness, connectors, etc., they have to be designed to take the load of these high voltage and high energy consuming components. So I think that is where these technologies help. And you have built enormous amount of capabilities for simulation, and you have the libraries where we can pull down what sort of systems can be used across the platforms, and thereby cut short the lead times for development. If you go just sequentially, then probably it's going to take even more time than a traditional IC engine, because it's a completely new domain. But using these tools and products, high-end products like this, I think you should be able to do it in a very short time.